So, building a 0.56 petahertz observatory. Being an electronica, I think in frequency, 0.56 petahertz happens to be the frequency of green light. And as Chris said, I'm a member of the Litchfield Hills Amateur Astronomy Club. A little bit about me. I was a member of ASGH 75-ish. At that time, I was interested in doing orbit calculations from 3 observations. Jordan Marche helping with the math. I'm still in contact with Jordan. We did the programming on my TRS-80, which so, member of ASGH, eventually was vice president and served maybe is the wrong word, but Pete Kenducker and I were president and vice president. And I'm still in contact with Pete today. Give you a timeline. In 1988, I was working with UTRC. They transferred us to the Optical Systems Group in West Palm Beach, Florida. In 95, we were under Hamilton at the time. They shut us down. Myself and 4 others pulled our severances, bought the business area out from UT, brought it back to Bloomfield, at which time reconnected with Pete and basically connected to the Litchfield Hills Group. At that time, we had maybe 5 members. It was very close-knit. We had a great time. Okay, so the goals. Observatory must not be offensive. It's going to be home for my 12-inch me ACF. Scope is heavy. Mark's home. Okay, maybe a little bit of inside club joke. Mark is another club member, and he happens to have a C11. So, I had to get a 12. So, we went down to High Point Scientific to pick it up, and it was sitting on the tripod. Yeah, I had no problem lifting that sucker off the tripod. But the real problem is lifting it off the deck onto the tripod. So, scope's heavy. Need an observatory. So we're going to have it on a permanent mount. The alignment's going to be held from session to session with a focus on imaging. The selection process, extensive search for what do we do in our backyards to house our scopes. There are basically 3 types of structures. We have a dome, roll-off roof, and a clamshell. Clamshell is just like it sounds, it opens like such. So, the dome, good sky access via the slit, excellent environmental protection from the breeze and any stray light, doesn't blend well. Got an immediate mischief factor. Any scrupulous kid walking by sees a dome, say, hey, there's some expensive stuff in there, let's go check it out. So, roll-off roof, excellent sky access, because everything is exposed. Consequently, it's got a fair environmental protection because breeze, any stray light, you're exposed. It does have a mischief factor because of the roof supports when the roof is open. Clamshell has basically the same sky access because everything is open. Minimal mischief factor because it looks just like a shed. And it's got, as you roll off, a fair environment protection. Okay, I chose the clamshell. It's kind of strange why I was last. Okay, I had built one in Bristol. That's when I was a member of the ASGH. At the time, I had a C80. Imaging with triads. That's film. I had done the detailed design of this version or this effort in Microsoft Visio. I've been told I spend way too much time on the computer. But doing the design in Visio kind of gave you a feeling for what you had to do and kind of where it was all going. So the pier is going to be made of cement and rebar, and no surprises there. Planned issues, and we all know it's the unplanned issues that get you. It's old murky, it's sitting in the wings. The pivot point of the hinges In other words, when that roof opens, you have the side of the structure, the roof is open. If the point isn't adjusted right, that roof is going to bind against the side. So that was a major tweak in the design. The pier center and height versus the declination axis position. Because the eventual building is going to be fairly small, I had to put the scope, center of movement, right in the center of the building. And I got a slide showing that, probably a little better. Snow load, yeah, we got snow up here. The apex beam of the structure needed to be supported. Okay, buildings. So now we've got basically what we're going to do. Well, how are we going to implement it? Again, it can't be visually incentive because it's going to reside in my wife's garden. An 8x8 footprint is probably desired. Internal supports are needed to support the hinges. T111 building, so I looked at that, and it just was kind of klutzy. By the time you have all the T111 panels, the 4x8 or 4x4, whatever you cut them down, you got these gaps, and now you got to trim it with 1x3 pine. It just, my wife kind of gave me the, so then I looked at Rubbermaid Big Macs, 7x7, slightly small. And again, spending so much time on the computer, I had a mock-up of myself sitting on a stool in this building, and it was very small. Duramax, that's a steel-coated vinyl building. My wife just looked at that. No, that's not going to go in her garden. Suncast Tremont. Well, obviously that's the one I chose because that's the last one. It's visually acceptable, an 8x7 footprint. It does have an 8x10 footprint available. Okay, so here's the Suncast Tremont. So what I did is in there, brochures or installation manual, did a screen copy, page into Visio, and scaled it such that now I have what this building is in real size. So here's the scope. You can see I spent a fair amount of time putting the scope in, and that's an accurate representation of the scope. So here's the declination axis, and it is middle of the building. So I use this graphic to determine the pier height and the pier offset so that the deck axis was in the middle of this building. Now, this probably isn't necessary if you got more room, but the whole thing is this is kind of, this is the lot we have at the house, and so, okay, we're going to go on. So, the foundation, nothing new here. It's all 2x6 pressure treated lumber. You can see that the foundation is separated from the pier so that you can walk around here and not induce vibrations into the pier. Okay, so we're starting. This is what my wife was looking at for quite a while. Here's the hole, about 4 feet deep. Actually, it was pretty easy digging because it was right next to my Litchfield. So here we are, got access to a cement mixer, and we're actually doing it. So here's the pier. Down, you see the rebar. This is kind of an intermediate interface to the eventual pier. This is the adapter plate for the wedge. I'm using a Milborn wedge. Okay, so here we are. We're building the foundation, so to speak. Completed. And here's the relief for the isolation between the floor and the pier. You can see, I think I need another round with the saber saw to give that a little bit bigger relief. And the infamous square, very important piece of gear. Okay, so you got the pier. Well, how do you put the actual wedge on it? So I got 2 pieces of 12x12 half-inch thick aluminum from MSC and some threaded rod, and proceeded to basically drill and tap such that now I have an interface so the wedge can sit on here, and a way of leveling that, that plate. Probably a mistake. If I had to do it again, I wouldn't use 4 screws, because to maintain this flat, that's kind of tricky. You don't induce a tweak into that top plate. Okay, so here's the finished interface. What's interesting here is the toolbox. I retired in 2013. I put that toolbox there, and it's still there today. I don't miss work at all. Although, when the minute people find out you have all this spare time, it's like, whoa. Okay, so here we are, we're putting the building up. This is my brother-in-law. He helped, took us about 6 hours to get a real shed-type building up. Okay, a new hinge design, which alludes to the fact that there was an old hinge design. I had done the initial Vizio stuff using a strap hinge from Home Depot that I had to bend just slightly to get this pivot point correct. It worked great. These are all 2x3s. Worked great without the roof panels on there. It's great. Put a roof panel on there, and that hinge just sagged. So I kind of had a minute of panic. Did some surfing, couldn't find any really heavy-duty screws or hinges. So I decided, well, call up MSC again, and I got some 4-inch, quarter-inch steel strapping and some 5/16 steel tubing. So it's actually pretty stout. The tubing may be a little bit misleading. And so I decided I'm going to make my own hinges. And so here we are, fabricating some hinges. I have a spreadsheet detailing just about every screw and nut and nail that I used in this project. And I asked my wife, I said, geez, do I have to include the capital equipment tooling to this? And of course she said yes. So anyways, I had to get a cut-off wheel, and my grinder was really, really weak. So here are the pieces. Here's kind of what it looked like. We don't want to look too close, because obviously I'm not a welder. I think I splatter more material than actually deposit. But we built several versions of these and no issues. Okay, so now we're actually going to make this shed an observatory. And so now you can see the internal structure to basically support the hinges. Here's the pier. Some of the stock supports came with the building. So now you can see we're starting to tie all this together. So, and here's the apex beam, and I used a aluminum angle, so I think it's 1.5 by 1.5 by 1/8, to basically give me support for any snow load. That might have been over-engineered, but okay. So now we're getting close. So here's the hinge, and you can see the idea. We had to do a little cutting here so that the hinges could work. Probably a better shot there. And here's the 2x3 framing. These supports, there's not a 90-degree angle on there. These were offset so that we could screw into the things on both ends. And so this gives you an idea of what the structure is going to look like, and that's without the roof panel. You can see that I have a severe sky limitation problem. But okay, it's what we have. Okay, so here we are. We're getting close. Here's the observatory with the panels open. Another shot. And so here's kind of a closer shot. We have basically the computer, the second monitor shelf. In the future, I have a table here, and we'll show you that soon. Okay, so parting pictures. So my wife got in there, and she's planted some, what are those, hostas? I'm not the gardener, I'm just the cheap labor to do the digging. Some arborvitaes, and her grandmother gave us that wheelbarrow, I think it came from Poland or something. Okay, let's say I have the costs. Total price, $2,600. As you can see, pretty much everything there is like 10 bags of sackcrete. Give you an idea of the pier. Okay, so here we are. We're actually starting to become an observatory. You know, my wife puts up with a lot. I'm sure anybody who has spouses in this hobby can confirm.
I like the fact that there are stars on the pot, though.
Oh, I didn't notice that. I'll have to tell her that she That tells you what kind of husband
A bit late for that, don't you?
Yeah. So, key thing here, bungee cord holding the wires going up to the mount. Okay, so here we are. Scopes basically peeking out of the top here. The roof panels are installed. Pretty much we're going along here. Another shot. Got the 6 meter, 2 meter, and HF, WA and RHT. Okay, lessons learned after 4 years. So, use a computer with a solid state drive. I was so nervous going out there at 0 or minus 10 degrees. It's the first thing is, what are you doing out in that cold? But I was always nervous about the hard drive just going, and the computer just becoming nothing. So I pushed a solid state drive in it. TeamViewer works great on the cold nights. I do have a second shed that's an electronics shop and that's heated and everything. So I basically run the imaging session from that shed, comfort. Any exposed plywood on the foundation should be covered. The foundation was built using their description and their tech manual, which I guess was an older revolution or revision because it wasn't quite right. It's actually, the building is a little smaller, so I have exposed plywood. And because it is my wife's garden, I do have an irrigation system back there that basically sprays the yard and the observatory twice a day. So that exposed plywood was getting moss, mildew, starting to delaminate. I said, oh, I gotta do something. And you look down here and you think I'm gonna add to flex tape. That stuff is unbelievable. So I use flex tape to basically seal that plywood. Flex tape or spray. Leaks. I had one stubborn skylight that always seemed to just drip in a heavy rain. Again, flex tape to spray, done deal. Roof panel joints. Again, I had one stubborn leak, very small leak between the roof panels. Again, flex tape. That stuff sticks. Don't ever think if you're going to put it down and peel it back and re-jockey it, ain't going to happen. Once you put it down, it is down. The corners develop some stress cracks, and I got a picture of that. And I hand wave that because the structure has internal 2x6s, and all the skin of the structure is basically screwed to the 2x6s with a big fender washer. So the structure is being constrained, thermal expansion. So it develops some stress cracks. Again, flex tape, which can be painted. You don't want my wife complaining.
Why don't you just make it all out of flex tape?
Make a good commercial. Make a weather shield for the door lock. Not a problem when it rains in the summer, but when it snows and the ice, the padlock is like frozen. So we fixed that. USB cables tend to corrode. So here you can see a cable actually I pulled out. This was a gold-plated connector, and this is just for scale. Gold-plated connectors, ferrite stuff. And what I've done to kind of help mitigate the problem is I pull the connector out, any connector, and reinsert it, and the idea is to get those connection surfaces to white and basically remove any of the oxidation or crack that's beginning to form. Okay, more lessons. Use a 12-volt linear supply. The switching power supplies are cheaper, but they generate noise. I started seeing noise in my dark furnace. So I bought a linear supply with the idea of using a remote sense. And what that does is the voltage regulating circuit, basically instead of looking at the voltage at the terminals, looks at the voltage right at the load and compensates for any I2R losses in the cable. And that was a problem because every time the TE cooler came on in the camera, the voltage would sag, and I could see that. Anyways, that regulator circuit wasn't stable enough to basically do the remote sense, so I just used some really hunky 12 gauge AWG wire, something like the RC car racers use to do their battery wiring. Put some ferrite chokes on the USB cables to help suppress the noise. Use shielded cables, you saw that in the previous picture, and then route those cables away from any cabling that's going on in the observatory that may have fast edges or generate noise. Linear actuators for automated roof opening. About 2 years ago, I developed an issue with my back where I can't lift anything more than about 40 pounds. And so I put in some linear actuators to open that roof panels, and it's like the observatory's got its own life. Plan for dew shields. Again, plan is the lesson learned. Okay, so when the roof is open, the panels acted like sails. And so the dome offers better wind protection because it doesn't have any sails. Some lessons are yet to be discovered. Okay, so here's the linear actuators. So between MathCAD and the Visio, I actually placed the actuators in the observatory. So between MathCAD and here, I determined the stroke and where to locate the actuators. And I got those from Frigorelli Automation. That's about $600. And so if you're a stout guy or a woman, you can do the 40 pounds, you can save yourself about $600 and do this whole thing for about $2K. Okay, so here we got some pictures. Got a linear actuator here, another one over here. Slight miscalculation, but okay, it works. You just got to readjust the timer and the temperature. Here's a stress crack patched with flex tape. Pretty good job. Here's the infamous rubber flap protecting the lock. Here's that flex tape. This is the actual floor that we saw previously. So that's wrapped around and all the way down to the 2x6. And basically, after that, I sprayed it with the clear flex seal, I guess it is, to basically seal that whole joint, so to speak. This is the Cat 6 entry, and just yesterday, that cable was bad. I don't know if anybody is experimenting with outdoor internet, but I'm just direct burying that cable. This is the second time I've had problems with it. If you do a data sharp check, the continuity and all the connections looks good, but that connector or that computer in there will not connect to a gigabit internet. Here's the scope. As I said, plan for dew shields. That's my flat frame. That's tight. That's tight. In fact, that's an AstroZap aluminum dew shield, and I called them. I said, hey, how long is that? And I went out and measured. Yeah, it just barely fit. Okay, so here we are in operation. Scope's peeking out. This is kind of a long shot going in. Kind of a ladder, or step ladder, to basically take the covers off the scope, the electronic finder, a guide scope. You're not going to get your face up in there to see where you're looking, so this is an electronic viewfinder. And so here we are at the operating station, obviously more white light than's needed. But you get the idea. It's a fairly compact setup. Okay, so it's wifey approved. She's added some decorations here. She's got her geese, and so she's happy, and which makes things a lot easier. Okay, so Mark, another version when neat. The club makes a pretty good habit of going down there pretty much every year, and I guess it was 2 years ago, Next Dome had a display, and it looked really interesting. It was like $2,800. Of course, Lee, my wife, said, that's not gonna fly in my yard. And so that's what kind of started this project. So when Mark saw the pictures of my stuff and showed it to his wife, well, guess what? This was all forest. So Mark spent far more than I did. But anyway, so here's an 8x10 version. There's his opening. This is kind of a long shot of him. He's actually got a desk in his. And again, the supports. That eats up a fair amount of volume if you really think about it. And so here's his Explore Scientific 127 along with a guide scope in operation. Okay, so here's some images that I've taken, and I was very nervous in seeing these because the last time we had an imaging show, all my dust motes and they all showed up. These look okay. Okay, so here's NGC 1514. What's cool on this is of course, the structure of the nebula and some of the faint nebulosity around that. Same thing with the owl, although it doesn't show up tremendously here, but there's a very faint ring around the circumference of the owl. This is, that's a, no, it's this mark through it. That's the dome here, yeah. So this is an 82, the cigar galaxy, and this is an NGC 6826. I struggled with this for such a long time to show the nebula, this I think is the blinking nebula, to show the structure of the nebula, along with this faint blue ring around this. The dynamic range here is just phenomenal. I think that blue ring is like 1 ADU off the sky. And PixelSight has, I think it's a background enhanced script that basically brought that out. So here's an M92, and what struck me with it, what's a little bit out of focus? What struck me with this was all of the colors, the blue colors in that globular cluster, and I always, when I'm processing, I'm kind of looking at the web as, okay, what am I supposed to be looking like? And so I checked out the web, and yeah, all those very young hot blue stars in that globular. This is M15. Another globular, and this was done at White Memorial, where the club observes, and this is done with my Explore Scientific 102. And my hat is off to you guys to do this stuff mobile. When you have an observatory, you are so spoiled. I got up there and I set up probably 7:30. I wasn't imaging until like 10, between finding polar alignment, where's the camera looking, where's the scope looking, where's the guider looking, doing the polar, it just was frustration with it. And then at CSP, same thing. So my hat off to you guys to do this mobile. Here's M1, again showing a lot of the structure. This is using some hydrogen alpha and triply ionized oxygen. And again, same bands with M27. Again, you can see the structure of both. Okay. My imaging equipment, me 12-inch ACF. The fork mount is a severe limitation, as the highest deck that I can get to is about 75, 78 degrees. It needs alignment routine. You have to do a polar home, which means you got to have the scope looking at 90 degrees. That means all the stuff at time focus for me has to come on. I'm using a 60 millimeter f3.8 with a ZWO for electronic finder, Moonlight Technologies, stepper focus system. I have a Solid Express Triax 694 monochromatic. I'm using some astronomical deep sky filter sets. They have an LRGB set, but the deep sky has sharper skirts. I had an 814C, a one-shot color, but was shown the light, literally, of doing RGB imaging. I've got an AMA 90 millimeter, 500 millimeter focal length guide scope. Picked that up at NEAT. It was like $180. Fantastic guide scope. I'm using a QHY 5L for a guide camera, and of course PHT 2.66. Prism for target and data acquisition. If you haven't checked out Prism, check it out. They have a really nice 80-day free trial period. It's got a very nice user interface. I've tried the Sky, AstroArt, several programs, Starry Night, and this is with a click, you connect the camera, and it cools down. Another click, it connects the scope with a mount, filter wheel, focus, boom. You're done. Very good. And the subframe calibration and integration functions are a lot easier than PixInsight. I use PixInsight for post-processing. It's a time sink. If you take the cost and divide it by the number of hours that you use, it's free. Okay, images by Mark. Mark, a fellow club member. So here's his M16 and the Flame Nebula. Last year we had the opportunity of getting 2 weeks at the 5-point gallery, where all the imagers in the club basically got their best and displayed them. And it was a very good success, as well as a pretty good cash event for the club. Here's another couple from Mark. We have M17, the Swan, and a piece of M45, the Police. Oops, wrong button, sorry. Mark's equipment, Mark uses he's got the second version of that Suncast scope, and he does have the luxurious 8x10 version. He uses a Celestron CGX mount, and when Mark and I are out, we're doing the texting and stuff, his mount is doing phenomenal. So much better than me. He's got the Explorer Scientific 127 and a Celestron 11, and he's a QHY fan. He's got a 183 and a QHY 10, which is one-shot color. And he just got the Chroma RGB filter set at NEAT this past year. Mark is using PHT 2.66, Maxim, Prism, and he also struggles in PixInsight. Okay, these are some images by Joe. He's our president, and he is the go-to guy for imaging. If you have a problem or a question, go to Joe. And it just so happens Joe is the guest. So I'm going to turn over the pointer to Joe so you can basically go through your stuff. Yeah, the laser's the top button here. And slide advance is this one here. What's that, Kim? Here, okay. Take the pointer and do your stuff. There you go.
Thank you. This is the area around the Bubble Nebula, which is NGC 7635. That's the one in the upper right side. And I did this view because this field of view because there's so many targets around it that I wanted to capture a little bit more than what the traditional view is of the Bubble Nebula. And you also have up in the upper right-hand corner the open cluster M52 and a beautiful cluster, beautiful nebula to the left, which is it's called the lobster claw. And then in this little area here, 7538 has the largest protostar that we know about at this point in time. This is all using narrowband filters, and I use the SBIG 8300 monochrome on an ED80. This one was done, in order to get all that stuff in there, I used a focal reducer. And I use a ZWO for my guide camera. I also use, PixInsight, trying to get a degree in that. It only takes like 10 years. This is about, I guess, about an hour and a half each on each filter. 5-minute exposures. And then how do you advance? This one, most of you probably recognize, it's part of the Veil Nebula. which is a supernova remnant, and the upper one is called, it's NGC 6960, which is the Witch's Broom. And the lower one is called Pickering's Triangle, and that's two of the three main nebulas in this area of the Veil Nebula. Again, it's using the Hubble palette in narrowband filters, very much the same, at about the same time frame in terms of the filters.
Okay, that's about it, I think. Yeah, okay, so Litchfield Amateur Astronomy Club. Our website is lhastro.org. On that website, we've got a fairly good selection of PowerPoint presentations that are downloadable on PDF. As you can see, we have a pretty strong imaging group. We have about 25 members, probably 10 or so imagers. We have monthly public lectures on observing. We've got a 14-inch meet in the Dor Hofflet Observatory. That observatory was the Mattatuck Astronomical Society's observatory, but that club is really struggling. We have a memorandum between our club and their club that we would overtake or take over the maintenance and the public observer for them. And that's located at the White Memorial Conservation Center in Litchfield, and that's just down the street from the state police barracks up there. So we need to get a rowdy crowd. State guys. We are an IRS 501c3 organization, and we just got recognized by the state of Connecticut as a recognized charity, so we can take contributions. Our club meets the second Friday of every month, except July, at the First Congregational Church in Harvard, Connecticut. Guests are certainly welcome. Are there any questions that you guys for me, Joe, or anybody? That was easy.
Great.
Thank you.
Thank you.